Hello, Math 7 students. This is mostly going to be a practice day. This is percent increase and decrease on other percent problems. So we will be spending some time on this. I'll mostly just be answering questions that come up. We will go over a few to get started to kind of see where we're at. We are going to start with this quick poll. So get this question answered, pause the recording to answer this question, and then we'll go over it when we return. All right, most students in class did really well on this warm-up. Let's go over it. The key thing to all of these problems, the ones that you're going to see on the worksheet that we work on today and this quick poll, is understanding what the question is asking. So the original price of a pair of shoes is $35. As we've been through other problems like this before, we recognize that this is the initial or the original amount, however you want to call it. This is what it is in the beginning. But you use a coupon and you get a 20% discount. So we know that we're going to be saving some money. This is a discount. It's how much we're going to save. I'm going to know what to do with that here in just a second. Pay attention to what the question is asking. What is the final price of the shoes? What is that final price? It is not asking what is the discount or how much are we going to save. It's asking for the final price. So meaning it starts at $35. We're going to get a 20% discount. After that 20% discount, what are we then going to be paying? So we need to make sure that we are answering the question that is being asked. And that is the only mistake that happened. The two students who made a mistake, you told me how much we're saving instead of what that final price is. So it's really important that we understand the question. We know what's being asked. Because I'm asking for that final price, I can now say 100% minus 20% is going to be 80%. That means that the amount that I'm going to pay is 80% of this initial amount. So 80% is 0.8. Let me just make sure that we understand that connection as well. 80% we don't calculate with the percents, we calculate with the decimal, and 80% is 0.8. Or if you want to, you can always change it to 0.80. The calculator is going to treat it the same. And we are multiplying that by the initial amount, which is $35. And when I do that, this is equal to n, the new amount. And then we can already solve this equation. It already is solved. N is by itself. We just need to calculate, and 0.8 times 35 is equal to 28. So in your calculator, typing in 28, typing in $28, most of you couldn't find the dollar sign, so you typed in the word dollars, and that's okay. It wouldn't work. Okay. So in the calculator, honestly, just the number is fine for something like this. Using the units is always great. It tells me that you understand the problem. And apparently the calculator doesn't like the dollar sign. On a test, on the paper, it would be appropriate to put that dollar sign. So let's get started on these problems. All right. Number 1, you go to the grocery store and buy a candy bar and a bottle of soda. The total is $3.41, and tax is an additional 3%. What is the total amount that you pay the cashier? Make sure we understand what's happening. You guys have probably seen this. You add up the amounts. Candy bar's 99 cents. The soda is going to be $1.43. But then when you go to the register, it actually says a different amount, and it says a different amount because of that 3%. So this is what you think the total is going to be based on those price tags, but then you have to pay that 3% tax. So the way that I would see this problem is with that additional 3%, that means I'm paying 100% plus that extra 3% for a total of 103%. And yes, technically that's one calculation, but it's a calculation that I could easily do in my head and understand that I'm going to be calculating with 1.03. 103% is equal to 1.03. See how similar this is to our last problem, our quick poll. Only difference here is that our quick poll, it was a discount. So we subtracted 20%. Here, it's an additional 3%. We're paying extra in taxes. So what do we do with this information? What we're saying is we are going to be paying 103% of the original price, or that price without the tax, which is $3.41. When I do that, that is going to be the new amount that I have to pay, the total amount that I have to pay the cashier. Type this into the calculator. And it does say that we're going to need to round to the nearest cent. So 1.03 times 3.41 is equal to 3.5123 to the nearest cent. When we're dealing with cents, that means I need tenths place and hundredths place. But that means I need to look beyond that to the thousandths place to figure out what's going to happen. And that too, how is that going to affect the one? Is it going to go up or is it going to stay the same? Gideon? Yeah, you guys know rounding, I hope. So what we're going to say is that we would have to pay the cashier $3.51. Any questions on that one? Okay, let's look at number 2, and then I'm going to let you guys just kind of practice. Number 2, it says a furniture company got a shipment of blankets. Each blanket cost $7.50. The company wants to make a profit. What does profit mean here? Anyone able to discern what that means based on the situation? Sophie? Yeah. Great, that's a fantastic explanation. So profit is how much money we actually make, how much we actually get to keep. So if we sell it for $10, we don't get to keep all of that $10 because we already had to pay the $7.50. So the profit would be just that extra amount that we get to keep after we pay all of our costs. So since we want to make a profit, they mark up the price by 40%. With that understanding, knowing that profit is going to be that little bit extra that we're trying to keep, they're trying to make 40% markup. So 100% being marked up 40% is going to give us 140% of the original. So again, the same process that we've been through. A markup of 40% means that we're adding that 40%. 140% means I'm going to be calculating with the decimal 1.4 or 1.40. And 140% of the original amount, or that cost, is going to give us what we need to sell it for in order to make that sort of profit. 1.4 times 7.5, and notice what I'm doing here. Even though it's not asking me to write the equation, I'm in the habit of writing that equation, using a variable for what I don't know. It's already solved, so I just need to calculate. And it tells me that this new price, N, is equal to 10.5, or in other words, I would need to sell the blanket, or the company needs to sell the blankets for $10.50 in order to make the profit. A different question might be, how much profit are they making? Notice that that's different than for how much should they sell the blanket. And if I were asking, what is the profit? There are two ways I could do it. I could answer this question first and then say, okay, they're selling it for $10.50. They have to pay $7.50 in the cost. So that's going to be $3. Or I could just go straight to that 40% of $7.50, and that calculation will give me the same thing. Okay, just know, make sure you're paying attention to what is being asked. The rest of these problems, at least, let's see, 1 through 8, even 1 through 12, I believe, are all going to be similar. The next set of problems, 13 through 16, that's where things get to be a little bit different. So I'm going to let students work on 1 through 12 first, and then we'll come back at the end and look at 13 through 16 together so that you can see how they're different and what the expectations are there. Okay, with your groups, finish as many as you can. Yes, Carter? I don't know. I haven't done that calculation yet. Are you talking on this one, round the $39.99 to $40? No, just keep it $39.99, because that's how stores do, right? They don't say $40. They say it's $39.99, so they can say it's under $40. Exactly. So just go with what that amount is. Always go with the exact amounts. Exactly. It's right. With that tax, remember, with tax, we're going to be paying over anyway. All right, good questions. Work with your groups. Pause the recording to get this done. Ready, set, go. Okay, students in class have had a chance to work on these, so only go on past this in the video if you've also had a chance. We're going to check our answers. 3 and 4, you can see the answers. 3 is $23.99, and 4 is $1,484. 5, 15 ounces for the family-sized bag of potato chips. And I wanted to talk about number 6. Carson earned $439 on his first paycheck, but 14% of that went to taxes. How much of his first paycheck did he get to keep? Notice the tax situation, and I want to go back to tax situation number 1. What had happened here? taxes. We had to pay an additional 3%. Am I going to be adding this amount here in number 6? No. So make sure that we understand the situation. In number 1, that's extra money that we have to pay in taxes. That's different than number 6, where we paid money in taxes and it came out of our paycheck. So we're still always paying taxes, but we're going to handle that one differently. Yes, Gideon? Number 4, you got something different? Okay. What did you get for number 4? No, that's right. I was not paying attention and I did it as if he gained that money in stocks, but he lost that money in stocks. You're right. So that would have been 100% minus 12%. Thank you for catching that, is equal to 88%. So what I should have done is 0.88 times that 1325, and that would show a loss. So typing that in, 1325 times 0.88, I got 1166. Is that what you got? Okay, good. Thank you for that. This is what happens when you don't pay attention to the problem. I treated that as if he gained money in his stocks because I didn't read it close enough. So thank you for catching that. Back to this though, taxes. This time he should have had $439 on his paycheck, but 14% of it went to taxes. That's less amount that he gets to see. So 100% minus the 14% that's going to taxes is equal to 86%. And so we are going to have that 439 multiplied by the 0.86. And that is going to give me the amount that he actually gets on his paycheck, what he actually gets to take home. And that is $377.54. How do you guys feel about that? Okay, 7. Sarah now weighs 267 pounds. And number 8, the Harrison family paid a total of $70.49. Some of it went to the grocery or the ticket for paying for the meal. The rest of it went to the server. Okay, checking the other ones here. Number 9, a question came up in class, so I want to address number 9. This is the first time we've seen this. Candace puts $200 in her savings account. In 2 years, she earns 1.5% interest. So how much money is in her savings account now? It's the same way that we've always handled it. 100% plus an extra 1.5% is equal to 101.5%. The question is, what do I do? How do I calculate with that? 101.5% is going to be 1.015. So yes, this time our decimal that we're calculating with has an extra decimal place value, but it makes sense because our percent also had a tenths of a percent. So 1.015 multiplied by the $200 that she has in her savings account, and we get 1.015 times 200. I got $203. Yeah? Okay. Again, checking answers here. Let me know if you guys have any questions. Number 10, 277.1 speed points. 11.304 meters. Yes, Oren. Thank you. So that would be 0.3 of a meter. Good catch on that. And 36,003 people. True story. I looked up the actual population, saw how much it changed. There was quite the population explosion in Tooele in 2000 to 2020. And now let's take a look at the final set of problems. Yes. Which is why it says round your answer to the nearest whole person, so we don't have partial people running around Tooele. No toes and fingers roaming around Tooele. It's whole people. Okay, voices off. Let's come back together. These problems are not percent increase or decrease problems. Okay, these ones are not percent increase or decrease. These problems ask you to find the percent, the part, or the whole, and I want you to use the specified method. So this is going to be similar to some other ones that we have seen, and I'm making them similar because we want to use percent proportions. So 70 out of 86 graders had missing assignments at the end of the term. what percent of 6th graders had missing assignments? Since it's, yes, too many, but again, this also came from a true story. Solve using percent proportion, or I could do a simple calculation, but if it's a percent proportion, that's going to be a ratio equal to a ratio. Remember that. When we have percent proportion, understand that a proportion is a ratio equal to a ratio. So that's what I'm setting up. Okay, and it says 70 out of 80. So that's 70 out of 80. And it is equal to what percent? We don't know. So a variable, but it's a percent, so that's per 100. So what does that really truly mean? Means we can solve this equation. X is being divided by 100. We can solve that by multiplying each side by 100. When I do that, I end up with X is equal to 87.5. What does that mean? That's 87.5%. Now, please keep in mind, I gave you an alternate way. I said, or a simple calculation. What am I really saying? 70 out of 80, I want to know what that percent is. I'm just saying, what's 70 out of 80? And 70 out of 80 gives me 0.875. Help me understand how this is correct, but this, using just a simple calculation, is also correct. We could discuss, because those are different numbers, right? So how are they both correct? How is it answering that question? Quick discussion with your groups. We're going to pause recording as they discuss. All right. Luke, your hand was the first one up. Go ahead. Mm-hmm. Mm-hmm. Yeah, exactly. Exactly right. So you're recognizing that in these problems, I'm taking a percent, turning it to a decimal, calculating with the decimal. In this version, it gave us the decimal. In this version, it gave us the percent. But they're both equivalent numbers. This is just written as a percent. This is written as a decimal. How do I prefer that you answer? With the percent. Since I'm asking what is the percent, I prefer this. So when you see this, just go that extra step and convert it to the percent. Okay, let's see if we have time to finish up the rest of them. 14. Last term, 90% of 7th graders had missing assignments at the end of the term. Also an accurate statement when I wrote this problem. 90% of 7th graders had missing assignments at the end of the term. There were 70 7th graders. How many of them were missing work at the end of the term? Solve using a percent proportion, a bar model, or a simple calculation. Again, you can use a variety of things, but I don't want us to forget this percent proportion. How can we set up that percent proportion? This is, once again, a ratio equal to a ratio. Carter, you have it? Exactly. X divided by 70 is equal to 90 divided by 100. 90% means 90 per 100. So we already have one side of that ratio written. We're asking for how many are missing, because that's a part we don't know, but we know that there are a total of 70 7th graders. So we can solve this by multiplying each side by 70. And when I do that, I end up with X is equal to 63. There were 63 7th grade students missing work. Again, it says you could also have done this using a bar model or a simple calculation. What would that simple calculation look like? I want to know. Oh, good, Grant, you know. Tell me. Yeah, 70 times 0.9. 90% of the 77th graders. So 90% of the 77th graders, and it's going to give us the exact same thing, the 63 students. Okay, let's finish up number 15. Last term, 85% of 8th graders, that should say 8th graders, I will fix that in future versions. 85% of 8th graders had missing assignments at the end of the term, which is 46 students. How many 8th graders are there? Again, all of these are true statements. And for the sake of time, let's just go over this together. 85%. is 85 per 100. And that is equal to, I know that there were 46 students who are missing assignments. I don't know how many 8th graders there are. Set up that percent proportion, and I don't like this. So the first thing I'm going to do before I even try and solve it is I'm going to flip it to its reciprocal. So I have 100 over 85 is equal to x over 46. And now I can solve this with one single solving step. X is being divided by 46, so I multiply by 46. And that leaves me with 46 times the fraction 100 divided by 85, and I get x is equal to, we're going to round to the nearest whole person here, 54. 54 total 8th graders. Now, 16, this one's going to be left as homework, and I will actually record the answer in the video, but for students in class, this is homework. Compare and contrast questions 13, 14, 15. How are they similar, and how are they different? That is your homework. I'm going to pause the recording so we can get cleaned up here in class, and then I'll come back and record the answer. All right, let's go over number 16. The obvious similarities is, of course, we're asking for the missing work among 6th, 7th, and 8th graders. But here's the key thing that I really want you to pay attention to. In number 13, I know how many students are missing work, and I know how many total students there are. What I don't know is the percent, or the amount out of 100. So we set up our percent proportion, and we're able to answer that question. In the next one, I know the percent, so I know that it's 90 out of 100, but there are only 70 students in 7th grade, so what I'm asking for this time is the part. I want to know how many are missing. In number 15, this time I know the percent, and I know the number of students that are missing work. What I don't know is the total number of students in 8th grade. But even though each of these things are giving different information, I'm being asked to find the other pieces. Notice that the percent proportion works the best for answering these types of questions. So to really truly sum up, I would like to point out that when we're doing percent increase or percent decrease problems, I really love this simple calculation. I really love just saying, okay, we're adding a certain percent, let's add that to 100%. Or we're decreasing by 15%, so we subtract that from 100%, and then it becomes a simple calculation. In these ones, where it's not a percent increase or decrease, but I'm asking just what is the percent, or what is the part, or what is that whole amount, I like that percent proportion equation. That's it for this lesson. Thanks for watching. We'll see you next time.